Okay, good afternoon to all of you. So now onwards, please use this ID. I think ID, that recurring meeting ID has expired. So now onwards, please use this new ID for my class. I think password is same. Is my AV is okay? Then we will start the class. Okay, thank you, Abhishek. Okay, in the last class, we have studied about the transmission loss, considering that one. Uh, this transmission loss is a function of active power generation. It may be expressed in index form, that is two summation marks. I explained it and we got the equation. Then also can be represented as in matrix form, like which you are seeing it on the screen. Understood? So for three plant system, so you can take PG as PG1, PG2, PG3, and B you can take 3 cross 3 matrix of B11, B12, B13, B21, B22, B23, B31, B32, B33. So then you simplify, so you will get this equation I said, isn't it? This is the equation, you are going to get it in matrix form. So this is also required. Either the transmission loss can be represented in index form or in matrix form like this. Till this point we have studied in the last class. Now today let us see why today so many different people are logging in. Okay. Anyway, I am not permitting them. Okay. Now let us see that one. So how the algorithm will work, this economic operation, how it works. So that we are going to see, and one numerical example we will try to solve it. Now equation 12 means the last equation which we have derived it considering the transmission losses, that is PGI, that equation. So that means you can see here, I will show you the final equation with transmission loss which we have derived. This one. This is your equation 12. So we have not numbered it. So you can number this one as equation 12. This one. Okay, let us continue this one. So that is the equation 12. So you have to solve this equation 12 using power balance equation 3. What is power balance equation? Total generation is equal to total load plus total losses. Understood? So that means what? Or you can write it total generation minus total load minus transmission loss equal to 0. That we have already represented in the optimization problem, that is in equation 3. For a particular load demand PD are solved iteratively on the following lines. Understood? So that means equation 12, the final equation what we got for PGI along with the power balance equation, that is equality constraint which we have considered including the transmission loss to be solved for a particular load iteratively. So what is the algorithm that we have to use it? So first thing is we have to assume the lambda. What is lambda? Is your incremental cost is equal to incremental cost lambda is also equal to what is the equation? dc by dci by dpgi. That is the incremental fuel cost. So assume first lambda is equal to lambda naught. Understood? Just one second. Okay, I think today some disturbances are there. Okay, next. So first initially you assume lambda is equal to lambda naught. Then assume the generation is equal to 0 for I is equal to 1, 2, 3 K. Is it clear? So this is the second step. First assume initial lambda, then assume PGI is equal to 0. Then solve equation 12 iteratively for PGIs. Understood? So each time you have to increment it. That is equation 12 PGI including the losses which just now I have shown it. So that you have to solve it iteratively. Understood? So next calculate the loss. Calculate the loss. This is indicated by equation 10. Understood? This is indicated by equation 10. This one. So this one we have to calculate it PL in index form or in matrix form. Just now I have shown it, isn't it? And check power balance equation. Now you see that's what I was talking about. Equation 3 here is nothing but your power balance equation. That is total generation minus load minus the transmission loss is less than or equal to some specified value. If it is yes, then we have to do. If it is not, we have to do some other thing. Understood? So this is the algorithmic steps you have to follow. First, assume initially the lambda value. This is how the economic operation is going to start. And how to assume this initial value of lambda, that I will tell you later. However, we have to assume it appropriately. If you don't assume it appropriately, then you will get improper values of generation. However, finally you will get the proper values because you are changing the value of lambda at each iteration. However, there is a rough procedure is there to select the lambda value. Okay. So now assume PGI, then solve iteratively, calculate the transmission loss, then check power balance equation. Because PGI is known, total generation, you can calculate it from the fuel cost equations, and PD will be given. PL is the new thing that you have to calculate it. Then you check whether this power balance equation is less than or equal to the some specified value epsilon. If yes, stop. Understood? So otherwise go to step 6. If it is less than the specified value of epsilon, then you stop. So that is the final equation. That will be the final solution. Otherwise go to step 6. What is step 6? So increment, first you assume some lambda, isn't it? Now increment this lambda. by delta lambda. Suppose if you assumed initial value of lambda as 15, 1, 5. Understood? So in the next iteration, that is you increment that one by delta lambda. It depends on the how accuracy you need. What is the accuracy in result you need? Depending on that one, you can select the increment value. So next you can say 16 lambda, you can say 16. Understood? So increase lambda by delta lambda if it is less than 0. If it is less than 0, that is if the power balance equation value PGI, total generation minus load minus loss, is less than 0, then increment the lambda by delta lambda. That is assumed 15, now you assume it 16. Okay, suppose if this power balance equation is greater than 0, then decrease lambda by delta lambda. Understood? So this is what you have to do. So increase the lambda if it is less than 0, this power balance equation. Decrease lambda if the power balance equation is greater than 0. If it is specified value, within the specified value, no need to go to step 6. Then you stop that one. So this will be itself is your final solution. Is it clear? Less than 0, increment lambda. Greater than 0, decrease lambda. So then what you have to do, go back to this step 3. So that means repeat from step 3. Understood? So repeat from step 3. That means again solve with the new value of lambda, solve equation 12 iteratively for PGI. Again solve this one, transmission loss you find out. Check power balance equation. Now here the power balance equation is with the new value of lambda. If it is so, then stop it. Otherwise again increment if it is less than 0, or decrement lambda if it is greater than 0. Any one will you have to satisfy. If it is less than 0, increment and come here, go to step 3 and repeat it. Or if it is not less than 0, if it is greater than 0, decrease lambda, then again go back to step 3 and solve it. So this is the algorithm which is required for economic operation, including your losses. Understood? So this algorithm they may ask you to explain for 6 marks or some 8 marks, 6 to 8 marks they may ask. Understood? Write the algorithm for optimal system operation or optimal generation scheduling, including the transmission losses. So this is the algorithm, you have to use it. Suppose neglecting losses, the same algorithm you can write it. So only thing is this minus PL you are not going to get. This minus PL you are not going to get. Here also minus PL you are not going to get. The entire algorithm almost remains same. Understood? Only thing is step 4 will not be there. After step 3, you check power balance equation. Now PL will not be there within the specified limit. Stop. Otherwise, go to 6, increment lambda, and this term will not be there. Neglecting transmission losses. If losses are included, this you have to include it. Okay, so this is what the algorithm you have to write it. Okay, fine. Now next, let us take this example which is there in your assignment also, second assignment in fact. Now you see a 2-bus system is shown in figure. Now you see this is a 2-bus 1, bus 2, and generator G1 is connected at bus 1, generator G2 is connected at bus 2. If 100 megawatt is transmitted from plant 1, that is this is plant 1, to the load. Where is load? This is your load. A transmission loss occurs 10 megawatt. Now here you see whatever the load is there, so this generator it can supply locally here itself, because generator is also connected here. So this becomes local generator for this load. So whatever it is there, so it can supply directly to this load. So when this generator is supplying power to this load, losses are neglected because it is localized one. So losses are neglected. However, whenever is power generated by plant 1, if it is transmitted through transmission line and it is going to the load. So it is transmitted. Whenever the power is transmitted, then you have to consider the transmission losses. So that's why he has given if 100 megawatt of power, active power is transmitted from plant 1 to the load, over a transmission line, a transmission loss of 10 megawatt. So a loss occurs across this transmission line as 10 megawatt. Find the required generation for each plant. Now this load is there, understood. Whether this load is satisfied from only one generator or from both the generator. If it is from both the generator, how the load, suppose if it is, this load is divided among these two generators G1, G2. Whenever G2 is supplying, no losses. Whenever G1 is supplying some power, losses will be there of 10 megawatt if it is transferring 100 megawatt. Isn't it? So how the required generation will be shared by each plant, and the power received by the load when the system is, when system lambda is rupees 25 per megawatt hour. What is this rupees 25 per megawatt hour? This unit corresponds to your lambda, is nothing but your incremental fuel cost, which is represented by DCI by DPGI. In turn is equal to IC, incremental cost. Understood? So these are the various things you should remember. Incremental fuel cost, lambda, in turn equal to your DCI by DPGI, in turn equals to your IC, incremental cost. This is how it is represented. Clear? So it is given as rupees 25 per megawatt hour. Incremental cost has been given. Then the incremental fuel cost. It is not the cost of generation. They have given incremental fuel cost. What is this one? They have given it DC1 by DPG1, DC2 by DPG2. Plant 1, plant 2, they have given it. With the load obtained at bus 2, here this is the load, find the optimum load distribution between the two plants for when losses are included but not coordinated. Understood? That means not included. When the losses are also coordinated. Understood? Losses are included but not coordinated. When the losses are also coordinated, then find the savings in rupees per hour when losses are coordinated. Now here you see there are three questions are there. Understood? So first question is here, find the required generation for each plant and the power received by the load. That means what is the generation at G1, what is the generation at G2, and what is the load? What is the load? That is, what is the power received by this load? Suppose if this load is receiving 150 megawatt, then what is the generation it is receiving it from G1? What is the power it is receiving it from G2? This is the first question has been asked. Then it says when losses are coordinated and not coordinated. So these two cases, what is the savings? What is the savings? So this is the two questions, major questions are there. This is the first question and this is the second question. In the second question, again we are having it 2 bits. Fine. So hope you understood this one. So first question, let us focus. Later we will focus on this one. Case A, case B, we will focus it. The main question is find the required generation. What is PG1? What is PG2? Understood? And what is the power received by this load? So that is when the incremental cost is 25 rupees 25 per megawatt hour. So that's why first you have to analyze the problem, understand it. So this is a test system, single line diagram. Now you see here, this is what I already have explained. Since the load is at bus 2 alone, isn't it? This load is connected at bus 2. So PG2, that means whatever the generation from G2, PG2, will not have any effect on PL. Obviously, no, that's what I said it. PL means it is transmission loss. So it becomes local generator. From here only, locally it will supply the power to this load. So it is not transmitted. Whatever the power generated by, delivered by G2 will not be transmitted over transmission line. So it will not contribute any losses. Understood? So since the load at bus 2 alone is PG2 will not have any effect on PL. So therefore, from the matrix form, what are the coefficients? I have written it. So what I think I have not shown it here. Okay, here I will show it to you. So what is B matrix? There I have shown it. Loss coefficients. Loss coefficients in matrix form. That's what I said. Transmission loss formula can be represented in index form or in matrix form. So in matrix form, PG transpose in matrix form, how it is represented? PG transpose B into PG. B is coefficients, cost coefficients. How it is represented? Because it is two plants, So obviously Bmn is equal to B11, B12, B21, B22. These are the transmission loss coefficients. This unit of this loss coefficients will be megawatt inverse. Megawatt inverse. That is, it is reciprocal of your active power generation. That is megawatt inverse. Clear? Because G2 will not contribute to any transmission loss. This B coefficient is loss coefficient. So therefore, whatever the coefficient connected to bus 2 will be 0. You see, B22, B12 is equal to B21 is equal to 0. Hope you understood why we have taken B22, B12, B21 is equal to 0. Because it is locally connected. It is not transmitting power over a transmission line. So therefore, this loss coefficient, this will not contribute to any losses. It will not have effect on PL. So effect on PL. PL consisting of B also will not have any effect on B. So therefore, whatever the elements, coefficients that are associated with bus 2, that is B12, B21 and B22, all are 0. Hope you got my point here. Understood? Okay, after making this one, now what we have to do? We have to compute B11, isn't it? We have to compute B11. All these values, 3 values are 0. Why we have taken 2 cross 2? Because it is 2 plant system. So that's why we have taken 2 cross 2. Understood? And it is a symmetric case. So B12 is equal to B21. Now PL is equal to, what is PG? PG1, PG2, because it is 2 plants. And B is this matrix. And what is PG? It is a column vector, PG1, PG2. Now we have to simplify this one. So what is the order of equation PL you are going to get? It is a quadratic equation, isn't it? Second order equation you are going to get. If it is a 3 plant system, then another element PG3, here also PG3, and here another 3 cross 3 matrix you are going to get. Is it clear? So this is the first step you have to do it, whether it is locally supplied or not, whether it is going to contribute for the transmission losses or not. So looking into that one, make some coefficients 0. Now we have to evaluate P11. So how to evaluate? Now you see. Now this, if you evaluate it, PL is equal to, now when you simplify, so you are going to get this equation. That is B11 PG1 square plus B22 PG2 square plus 2B12 into PG1 PG2. You multiply these 3 matrices. So you will get this equation. First B11, B22, then B12 into PG1, PG2. Okay. This is the equation you are going to get. From this matrix multiplication, you are going to get this one. Now in this equation, B22 is 0, B12 is 0. So therefore, what is left out? PL is equal to B11 into PG1 square. So that is equal to PG1 square. PL is equal to B11 into PG1 square from this equation, because B22, B12 is equal to 0 here. Okay. Now here PG1 has been given, that is power transferred from plant 1 to the load is 100 megawatt. In the problem it has been given. Power transfer from plant 1 to the load is 100 megawatt. That has been given. And while transmitting this 100 megawatt from plant 1 to the load, so it incurs a transmission loss of 10 megawatt. A transmission loss of 10 megawatt. So PL has been given as 10 megawatt. Substitute these values here. So we will get B11. Substitute these values. PL has been given 10. B11 we have to find out. PG1 has been given. So therefore B11 is equal to 0.001 megawatt inverse. So units are important. You have to specify these things. Have you understood this one? B11 value got. Now you see all the elements of this P matrix coefficients, that is loss coefficient matrix, you got it. Okay. Now what is next? We have to find out the load. What is the load? So what is the load and what is the power received from G1 and G2? We have to find out. So for that one, you have to consider the coordination equation with loss. What is the coordination equation with loss? Equation 6. In the previous class, the same number I am taking it here. and I have repeated here for your convenient purpose. So lambda is equal to dCi by dPgi 1 minus dou PL by dou PGI, or otherwise lambda of cross multiply. Lambda of 1 minus dou PL by dou PGI is equal to dCi by dPGI. Okay, or otherwise finally what we have written, dCi by dPGI, we have written it as ICI, that is incremental cost, is equal to lambda into this one, isn't it? So 1 minus dou PL to dou PGI, we have replaced with here, this one is this one with ITL. What is ITL? Incremental transmission loss. Dou PL to dou PGI, this term, we have replaced with incremental transmission loss. So lambda of 1 minus ITLI is equal to ICI. This is nothing but your exact coordination equation, which we have derived it in the last class. Understood? That's what we have derived it. So from this equation also. So the coordination equation, you can call this as a coordination equation, or further simplification, it is lambda of 1 minus ITLI is equal to ICI, further simplification of this equation 6. Okay, this is what we got. Now in this equation, it is a simple, you see this one, cross multiply. So here is equal to, for first generation, okay, DC1 for this one, DC1 by DPG1 plus cross multiply lambda, isn't it? So plus lambda, then minus lambda into dou PL by dou PGI. This is what we got it. So that minus whatever it is there, so that we are getting it on the LHS side, and we got this equation. Hope you understood this one. Just cross multiply this one. So it becomes on the LHS side lambda minus lambda of dou PL by dou PGI on LHS side. So that minus lambda dou PL dPGI, I am taking it on to RHS side. So that means it will become DC1 by dPG1 plus lambda dou PL to dou PGI is equal to lambda. Just cross multiplying this one. Okay. Now from this one, what is DC1 by dPG1? In the problem it has been given. For plant 1, what is the incremental fuel cost equation? It has been given. What is the given? It is 0.02 PG1 plus 16, this term. This is your DC1 plus lambda. Lambda has been given it as 25. In the problem it has been given. Hope you understood this one. Then dou PL to dou PGI. Dou PL to dou PGI. How to get? Can anyone tell? Dou PL to dou PGI. How to get this dou PL to dou PGI? I have written it already, it is visible to you, but how? Can anyone tell? Put it in the chat box. Or you can unmute yourself and you can answer. Differentiating PL equation, Abhishek Sharma. Yes, that is the right answer. So this is the PL equation we got. This is the PL equation. So dou PL to dou PG1. So here you can write it is PG1, this one, instead of PGI. First plant, we are treating first plant. So therefore I is equal to 1. So it is dou PG1. So take partial derivative of this one, dou PL to dou PG1. That is this term is equal to 2 times B11 into PG1. That's what I have written it here. 2B11 into PG1 is equal to lambda. Lambda is given it as 25. I think you understood this one. From the coordination equation, cross multiply, arrange the terms, then whatever the data that has been given, substitute it here. Now here, B11 value is known to you, 0.001, and PG1 is unknown. So from this equation, solve for PG1. Solve for PG1. B11 is 0.001. That you substitute. Solve for PG1. So when you solve for PG1, so what is the value? Can anyone tell? Fast. What is the value of Pg1? Okay, I got the answer from Sushumna. Any others? What is the answer for Pg1? Abhishek Sharma has given some answer. So Sushumna has given 128.57 megawatt. Sumant has given 128.57. Abhishek has given 225 megawatt is the value of Pg1. So let us see that one. So when you solve it, this one substituting, so it is 128.57 megawatt. So in this step, just substitution I made it B11, then solve for Pg1, so you'll get 128.57 megawatt. Okay, now Pg2, we have to find out. What is Pg2? You take the second cost equation for the second cost equation. Understood? Same coordination equation, same equation for plant 2. For the plant 2, what it becomes? dC2 by dPg2 plus lambda into dou PL to dou Pg2. Dou PL to dou Pg2 is equal to lambda. So this is also a coordination equation. This coordination equation for plant 2. So this becomes dC2 by dPg2 plus lambda into dou PL by dou Pg2 is equal to lambda. So dC2 by dPg2, it has been given in the problem. The incremental fuel cost for plant 2 equation has been given. Lambda is given and dou PL to dou Pg. Now can anyone tell, I have given the hint, what is the value of Pg2? What is the value of Pg2? What is the value of Pg2? On the same lines, you perform, that means using coordination equation for plant 2 on the same analysis, what is Pg2? Let me check who will give the answer. First, I hope you understood that coordination equation for plant 2. The corresponding suffix 2, you use it and substitute the values given in data and solve for Pg2. I think it is easier than the first one. No complications here. I don't know why you people are taking so much time. So maybe you people have not understood. Yes, I think you people are taking more time to give the answer for Pg2. If I write it, you will come to know the equation. Okay. Once again, I am telling you, same equation, okay, for plant 2, how we are going to write? dC2 by dPg2. dC2 by dPg2, in the problem, some equation has given like this. These two terms are like this. It has been given in the problem. Plus lambda is given 25. Dou PL to dou PGI. So dou PL to dou PG2. Here, this becomes dou PL to dou PG2 is equal to lambda. Substitute the values of dC2 by dPg2, lambda, dou PL by 2 dou PG2 and lambda, solve for Pg2. This is what I said. So what is the answer? Pg2. Are you there or feeling hungry and you went for lunch or what? Come on, come on. Yes, Sushumna has given, but doubt. She has put a question mark, not sure about that one. Is it so? If I write the formula, then it will be easy for you. You have to think of it. The same equation, you write it, substitute the values. No doubt. That's why you have put a question mark. You have given the answer with question mark. Anyway, I will clarify that one now. Others, at least you try. It is easy, no need to think so much. In the coordination equation for plant 2, substitute the values which are given for plant 2. Abhishek, Sumant, anyway, I think not followed. So Sushumna somewhat she has tried it. So now I will give it here. Now you see here, this is the equation I given it. Abhishek has given 250. I don't know how. Now you see here. So dC2 by dPg2 is 0.04 Pg2 plus 20. This is the equation which has been given in the problem for dC2 by dPg2 plus lambda, that is 25, into dou PL to dou Pg2. Dou PL to dou Pg2, isn't it? So dou PL to dou Pg2, what is it? Okay, some other answers, I'm getting it. Okay, Abhishek has corrected to 125. Okay, Gunasmita has given, Tushar has given, now everyone are giving 125. Because I have written the equation there. Because I have written the equation, so obviously it will become easy for you. So therefore, B22 is 0. So this entire term is 0. So is equal to 25. So 25 minus 20 is 5. So therefore, Pg2 is equal to 5 divided by 0.04. That is 125 megawatt. This is equal to 125 megawatt. Clear? Okay. Now otherwise also, now here you see this one, this equation, simple way I will tell you. This equation you are writing for plant 2, isn't it? Is this plant 2 contributing any transmission loss? Is this plant 2 contributing any loss while transferring the power to this local load? Initially I said it, so it is not contributing any losses. Only plant 1 is contributing. So that's why we have taken this one. So this is the equation for plant 2, we are writing it, coordination equation. So therefore, this without looking into anything, complications, so this term will not be there. This term, because this term corresponds to your transmission loss. Is plant 2 is giving any, is contributing any losses? No. So therefore, this transmission loss term will not be there for plant 2. Directly, dC1 by dPg1 is equal to lambda. So what is dC1 by dPg1 is equal to lambda? So this is how you should get it. That way also you can do it. isn't it? So DC1 by DPG2, DC2 by DPG2. So this term, entire thing, instead of showing all this expansion and substitution, it is not required. So generally, by common sense, looking into the network given, plant 2 is not contributing any losses. So therefore, in the coordination equation, the term corresponding to transmission loss will not be there. So therefore, DC2 by DPG2 is equal to lambda. That's all is your criteria. So you will get PG2 is equal to 125. Now what is the total load PD? Can anyone tell? Let me see. What is so now it is almost a time up. Can anyone tell? Fast. So once after getting this answer, I will end the class. What is total load demand PD now? What is the total load PD? Already I have given it. The equation. Power balance equation. Please remember this word. Power balance equation. In interviews, anything, if you are going it for competitive examination, they will say, what is power balance equation? Is equal to total generation is equal to load plus losses. That is your power loss equations. So now I am getting the answer. Location has given the answer. That is the total load, the value. Others, what is the load now? Use the power balance equation and tell me what is the load. PD. PD is the load. Load is not specified there. So we have to find out the load also. So what is the load? Okay, Shanti Prasad has given the answer. Use the power, this is the hint. Use the power balance equation and find out. Okay, anyway, I think the right answer, location Shanti Prasad has given. So that is, you can see here, PL is equal to, you can see this one, 16.53 megawatt. Let us check what are the values they have given, whether it is right or not. PL, this is the now transmission loss, is equal to B11 into PG1 square. B11 is 0.01, PG1 is 128.57. Okay, I think other answers, already I have shown it now here. 237.04, Tushar has given. Okay, now here you see this one. This is the total loss now. Now you can see PD is equal to total generation. Total generation is two plants are there, PG1 plus PG2 minus PL. What is PL? 16.53. Understood? So that is equal to 237.04. Understood? So the mistake what Abhishek and others, those who are given the answer, you might have taken PL as 10 megawatt. PL as 10 megawatt, isn't it? So what they are saying, 10 megawatts is the power that may occur. But actual losses with this generation, see 10 megawatts loss is when the plant 1 is transferring power of 100 megawatt. Please remember this one. This is again a common sense. The 10 megawatt transmission loss has been given when a plant 1 is transferring 100 megawatt of power. Understood? Now, what is the power actually which is generated at plant 1? It is 128.57. So for 128.57, what is the transmission loss? So therefore, PL equation is equal to B11 into PG1 square. B11 we know, PG1 is this value you substitute it. So this is the actual transmission loss. This is the actual generation at plant 1 and this is the actual loss that is happening. Hope you got this point. So that's those values you have to substitute it. So you'll get 237.04. I think you got confused with that 10 megawatts which has been given in the problem. 10 megawatts is the transmission loss when the plant 1 is transferring a power of 100 megawatt. Understood? But here what is the generation at plant 1 PG1? 128.57. So when 128.57 is power transfer, what is the corresponding loss? So you have to find out. Then you substitute that one in power balance equation. This is your power balance equation 237.04. Hope you understood that one. Still, there are another two cases are there when the losses are not coordinated, when the losses are coordinated. This one, we will continue this one in the next class. Okay. Okay, any doubts? Okay, thank you, Nadal. Take care. Bye.